Hello everyone, today we're going to cover some general concepts. First, let's talk about the libraries. Libraries are programs that implement common shared functionalities. Usually, they are written by other people. Most modern programming languages today provide standard libraries. They offer basic functionalities such as print something on the console or write some contents to a file. 99% of your time can be saved by just using someone else's code properly. The general rule of thumb is do not waste time doing trivial things. As a professional programmer, 90% of the time will be reading others' code, like how to properly use libraries or Googling to find the best library to use. We mentioned OS multiple times already, so what's exactly an OS? That's a big question worth some credits if you chose CS major. There's a dedicated class for OS. In short, OS is a piece of software which manages hardware and software and provide common services for apps. These services are usually called API, meaning Application Programming Interface. You can treat them as the access points to OS provided libraries or functionalities. For example, creating a network connection is usually a function provided by OS APIs. According to Wikipedia, Windows is dominant on desktop and laptop, and Android is on mobile phones. Since Android is a Linux distribution, so it's true that Linux is dominant in mobile. Apple has Mac OS and iOS. They are influential but not dominant. On a very high level, you can think that computers works like this block diagram. Each white block is a program, which means someone wrote code for them. That starts from the lowest level firmware to the kernel of the OS, and then framework, shell, services, and apps. Each operating system has its kernel. Depending on the operating system, the role of the kernel varies. Take Android or Linux as an example. The kernel is responsible for 4 jobs: memory management, process management, device drivers, system call, and security. We briefly discussed memory management, and yep, that's mostly done by the kernel. Process is a basic unit inside OS. In Android, it is roughly equivalent to a running app. Modern OS has kernel and user space. This is done so for security concerns. Only kernel and drivers are in the kernel space. They are capable of controlling the hardware. All other programs stay in user space, which is less privileged, meaning that they cannot directly control the hardware. Instead, they need kernel to do that for them. Modern OS often is accompanied with a framework, a shell, and some services. Together, they offer fundamental APIs. For example, drawing something on screen, create a network connection, etc. Shell can be in many different forms, like Android Launcher, Windows Explorer, or command lines like Linux Bash. We interact with Shell one way or the other because Shell is where to start apps. So how exactly is my program run? You have run the Hello World program, right? It's run from Windows Command Prompt or Mac Linux Terminal. These are text-only shells. The Hello World program does not look like a normal app because it's text-only. Well, it's not. We start from simpler things. That's what computers can do 40 years ago. And we'll dig in deeper in the demo. Now I'm opening my VS Code. Navigate to the quick start.java. On line 3, I put a breakpoint. Just click on the left of the line. There will be a red dot. This tells the debugger to stop there so that we can inspect this program while it is still running. I'm going to show the beauty of debugger. Now click on the debug link. The program executes and paused. On the left pane, something shows up. So we click on it. There are 4 subpanels here. Variables and watch are for data inspection. That lets you check value of variables during program execution. We'll explain these concepts later. The call stack shows something interesting, and let's expand the main thread. It is currently stopped at line 3 as expected. Let's step in, which means to dig in execution of that given line. You can see the call stack change. A new file printstring.java shows. And printstring.println is shown on the call stack. This is the standard library is being called. See the system.out, the println. It's calling the Java library. Java library is offered by Java. Again, it is written by someone else, and the debugger lets us see the code. You can further step in like this. And observe the call stack growing. Say if we are not keen in seeing all the nitty-gritty details here and want to skip some, you can use the step over. It will skip the details and move to the next line. If I want to go up to previous level, then I just use step out. It will finish the current level and go back. Now observe the watch on the left. You can see some variable being published. This allows us to inspect variables. The debugger is an important tool for learning to program. As mentioned in the beginning of this class, everyone makes bugs. Debuggers are created to debug. So make good friends with them. Also, this demo shows library in action. Java comes with a super rich set of library. As a result, don't try to reinvent the wheels. Always check if there were already existing library functions that you need. Chances are, most basic data structures and algorithms are already provided. And this is all for today. Thanks for watching.